This video is about understanding the geometry of absolute value inequalities. So, if we take a look at two relatively simple absolute value inequalities that we've already done problems like, if we have the absolute value of x plus 6 is greater than or equal to 3, we could algebraically solve this and get x is greater than or equal -3, or x is less than or equal -9. Likewise, this problem we could solve and get x is less than 4 and x is greater than -8/3. And I want to show you that we can also do this from a geometric perspective and get the exact same answer understanding what's happening with absolute value. So, absolute value we described as a geometric principle of understanding the distance from something. So the absolute value means that we have some sort of distance that's being utilized or understood or something like that. And so what we're saying here is that some sort of distance must be greater than or equal to some sort of value. So this also represents a distance. So the distance away from something must be greater than or equal to something else. So in this case, how we may look at it is if we look at the original understanding of what absolute value is, absolute value of x being a distance greater than 4, for example, when we initially graph that, that essentially means the distance away from the center of the graph, which is 0, must be greater than 4. So that means 5 would work, 6 would work, 7 would work, 3,000 would work, but also -5, -6, and -3,000, they would work too because those distances are greater than 4 from my center of my graph, which is 0. And how do I know the center of my graph is 0? What happens if I substitute in 0? I would get 0. That would be the smallest distance that I can possibly have, would be 0, right? So if I look at the geometry behind this situation, how do I figure out the smallest possible distance? Well, I have to make whatever's on the inside of the absolute value equal to 0. So in order to figure out the center of my graph, I would take x plus 6 and set that equal to 0. So the center of my graph is -6. So at -6, I have the center. The other thing we have to figure out is the radius. The radius is the distance away from the center that I can possibly be. The distance must be greater than or equal to 3. So my radius in this problem is 3. So now let's think about what that means. -6, I can go in either direction because a radius, just like in a circle, I can go in any direction. So a radius of 3 moving to the right would get me -3, and moving to the left would get me -9. Notice that that's exactly what we got algebraically. Now, how do I figure out where to go? Since this is greater than or equal to, my distance must be greater than or equal to 3. So that means I will have to go further out away from -6, which is my center, in both directions. So this is how I would solve this problem graphically using geometry. And then my final answer would also have to include some interval notation. So -∞ to -9 union -3 to infinity. So I still have to solve it. It's just using the geometry of it kind of helps me understand it. Now let's take a look at the geometry of this one. I have to figure out my center still. So my center is from, I take the 3x minus 2 and set it equal to 0. And so I solve and I get x equals 2/3 as my center. So the center is 2/3. Now my radius, I may be tempted to think is 10, but that doesn't fit with what my answers are. So notice if my center's at 2/3 and I know that I have something at 4, and I know I have something at negative 8/3. Clearly, 2/3 plus 10 does not give me 4. So what's happening is this number actually does a stretch of some kind of our radius. And our radius always gets stretched by the reciprocal amount of this. So I take 10 and I divide it by 3. So whatever number is multiplied by the x on the inside of the absolute value, that's what I have to divide my radius by to get what I actually have for my radius. So notice that 2/3 plus 10/3 gives me 12/3, which is 4. That represents this. 2/3, my center, minus 8/3, or I'm sorry, minus 10/3, which is my radius, to the left will give me negative 8/3. So as you can see, I still get both of these answers using geometry. I just have to understand that the radius gets divided by what's on the inside of the absolute value that's getting multiplied by x. So I have from negative 8/3 to 4. And how do I figure out where to go? Well, since this is a less than sign, so the absolute value is less than, that means my distance has to be less than my radius. So that means that all of my answers are between negative 8/3 and 4. Because if I went this way, that would be too far away. That would be bigger than 10/3 for a distance away from the center. So once again, I have to finish by writing the interval notation of the answer. So x is between negative 8/3 and 4. Now, what if we have problems that are a little bit more complicated looking? Step 1, we always still have to isolate the absolute value. So if I subtract 10, I have negative 4, absolute value of 2x minus 7 is greater than or equal to negative 32. And then I divide by negative 4, so I have the absolute value of 2x minus 7 is less than or equal to 8. Once I isolate the absolute value, now I could still do this algebraically, but we've done that a ton of times. I'm just going to focus on the geometry. So the geometry of this situation, notice that my center, the center of my graph is when 2x minus 7 equals 0. So x equals 7/2. Then my radius is going to be 8 divided by the number that's multiplied by the x. So my radius is 4. So that means if I take 7/2 plus 4, center plus radius, and 7/2 minus 4, I'm going to end up getting the values that I need. So 7/2 minus 4 gives me negative 1/2. 7/2 plus 4 gives me 15/2. And then I know that I'm going to draw the graph on the inside, because when I look at what happens when I isolated the absolute value, my distance has to be less than or equal to something. So my answer would be negative 1/2, negative 1/2, 15/2, both in brackets. And I can solve this super quick just to make sure that I know what I'm doing in terms of the geometry. So 2x minus 7 is less than or equal to 8, or greater than or equal to negative 8. So if I add 7 and divide by 2, I get x is less than or equal to 15/2. And x is greater than or equal to negative 1/2. So notice that the algebra matches the geometry. Finally, we'll do one more example. So if I add 16, I get 2 times the absolute value of 3x plus 4 is less than 28. Then I divide by 2, so I get absolute value of 3x plus 4 is less than 14. So now I can take the center. The center is when 3x plus 4 equals 0. So x equals negative 4/3. And then my radius is taking 14 and dividing it by the number that's multiplied by the x, which is 3. So now I can take negative 4/3 add 14 thirds. That gets me the number over here, which is going to be 10 thirds. I can take negative 4 thirds and subtract 14 thirds, which gives me negative 18 thirds, or negative 6. And then it's once again on the inside since the distance is less than. So my final answer would be negative 6, 10 thirds in interval notation. And of course, this still works even if we restrict the domain. So for example, if I restrict the domain of this to only be integers on problem number, I guess I didn't number the problems. So problem this one, if I restrict the domain to be integers, I can still do this. So my original answer was negative 1/2, 15 halves. I just have to restrict this to make sure that I only have integers. So the first integer that I would get is 1, 2, 3, 4, 5, 6, 7, because 15 halves is bigger than 7, so I can't get to 8. So I would write it as 1, 2, 3, 4, 5, 6, and 7. So I still can get this. I just have to use my brain after I get it. Like, I can't think that the answer is always going to have the center of 7 halves here. Like, once I have some sort of restriction, that doesn't mean that the center is going to be also the center of the restriction. But it can get me to the point where I know what the answers are, so then I can restrict the answers if I have some sort of domain restriction.